others. Others.
Hello. Okay.
Yeah, you should mute yourself.
Yeah.
Hello everyone. Very good evening to you all. By the way, am I audible to all?
Yes, you're audible.
Okay, good. Well, we are just waiting for the other participants to join in. We'll start in next 2 or 3 minutes. Well, I think we can start now. So once again, very good evening to you all. It's good to see you all here again. Well, so if we talk about this session, so this session is primarily be organized for discussing the doubts that you may have in activity and practice category questions for week 2. So we'll be addressing some of the common queries that we have come across in the discussion forum. So we'll be discussing those here, and we'll take all of your queries that you may have in regard to those questions. Am I audible to all?
Yes, sir.
Okay. Okay, great. Nice. So before we start this session, I would just like to know that we have around 15 people in this meeting. So how many of you have completed watching the lectures for the week 2? Yeah, just raise your hands here. Okay, wow. Have a lot of people. Okay, 7 people have already finished watching complete week 2 videos. Okay, even more than that. Okay. Well, it's great to see this thing. Okay, and how many of you have attempted all of the quiz? The activity and practice questions? Okay, nice. Great. So hope we will have enough queries to discuss in the Yeah, I'm sorry, I lost my connection now. Am I audible to all? Yeah, am I audible?
Yes, sir.
Yeah. Adarsh, am I audible?
Yeah, Abhishek, you're audible, but your like your video is lagging a bit. So, would you mind switching it off? You can speak like this, I guess. Then once it's the network becomes stable, you can continue.
Okay, is it okay?
Yeah, it's fine now.
The voice stream fine? Okay, great. So yeah, I was just saying that we'll start as usual, that we have done in the past live sessions, whatever have been conducted for this application development course. We'll present some of the slides in the Mentimeter. We'll involve some discussion there, and then we'll start taking up your queries. We'll discuss all of the common queries that we have come across in the discussion forum. So I'll just start sharing my screen. Well, is my screen visible?
Yes, sir.
Well, I would request you all to please go to menti.com. Please log on to menti.com, and when you are asked for any for a code, please enter this code mentioned here on the screen. The code is 77144770. Yeah, thanks a lot, Kumar. Yes, so please log on to menti.com. We'll just wait here for 1 more minute. Yeah, okay, we have got one query in the chat from Bimlesh. Yeah, Bimlesh, we'll try to demonstrate the whole process once again here in this session. Well, I would request each of you to please go to menti.com. We have around 20 people in the meeting, and just 9 people have been connected here with the slides. Okay. Yes, Preeti, we will be addressing that issue here in this session also. So, others, shall we go ahead or shall we wait for more people to join?
I think we can go ahead now.
Well, I'll just go to the next slide.
Yeah.
Well, this is the first question that we want to discuss here in this session. So I would request you all to please refresh your screens if you are not able to see this question, or there will be a prompt of something like next question on your screens. So please hit that button. So Adarsh, I guess you would like to take it over. Over to you.
Yeah. So I guess we'll wait for some of the responses and then I can talk.
Yeah, sure.
By the way, I'm audible, right?
Yeah, you are audible.
Yeah, okay.
Yeah, Adarsh, we have got enough responses, so let's start the discussion. So this is the result that we have got.
Yeah, so it seems that out of 14 responses, 12 of them have given all as the correct answer. So yeah, so I guess most of you are clear with this concept that the term here, the series of bits given here, that is 0 1 0 0 0 1 0 0, can be interpreted as sequence of bits also. It can also be interpreted as number of decimal value 68, and also with the character D, especially in the ASCII encoding, right? So yeah, so the main virtue of having this question is to show that yeah, so there is a change in response now. Why so? All right. So the main virtue of having this question is to say that particularly unless and until we specify to what context we are using this series of bits, we can have all this answer stated down, right? So when I ask you what does this series of bit means, it also means the sequence of bits. At the same time, it will mean a decimal number 68, which is an ASCII representation, or decimal representation, and also it would represent the character D. Okay, only that it depends on what is one thinking. If I'm a person, I'm thinking I am very good at converting these bits into ASCII alphabets, it would be very easy for me to say, yeah, it is a character D. But is that the only thing I should have in my mind? No, I should also look at the whether this set of bits determines some number, a decimal value of the decimal value. Yeah, so that is 68. And if at all I do not have any context in my mind, I can simply say that, okay, this is series of bits, right? So what we want to say here is it is very much possible that a particular set of bits can represent multiple things, and obviously it should be relevant. And the representation or the interpretation that we do majorly is based on the context of the information that we get to see from that bits, right? So that is the reason we have we can simply say with a empty line, we can say that it is sequence of bits. The number with decimal value 68. Okay, so what do you think is 0100 0100 code is? So it is nothing but an 8-bit binary code, right? So if I try to convert it into decimal code, I'll get the number 68. How do I convert that? I'll start from rightmost. Okay, so I'll start from the rightmost bit, that is called as the least significant bit, all the way to the leftmost bit, that is called as the most significant bit, and multiply and raise the power of 2 to every place value where there is 1, right? So I have 1 at the third value from the left, and at the 7th bit, the third bit and the 7th bit. Okay, and in binary, how do we start it? We start it from 0, right? So 0 1, if I look at the place value, I'll write 0, and I'm starting from the right. Okay, so I'll say 0 1 2 3 4 5 6 and 7. So I have 1 at 2 and 6. So what I'll do is I'll raise this 6 and 2 with the 6 and 2 to the power 2, and then add them. Okay, raising 2 to the power 6 would give me 64, and raising 2 to the power 2 would give me 4. So adding them, I'll have 68 value. So this is simply a conversion of binary number into a decimal, which equals to 68. Okay, so to have option B as my correct option, I would have to think a bit more than sequence of bits. Okay, now if I have information about ASCII bits, okay, each decimal number can be represented as an ASCII bit. Okay, so I can move forward to saying that this bits or this series of bits 0100 0100 can also represent capital D, right? And for that I need to there is one possible ways of knowing that this particular number corresponds to D, right? So I guess you may have seen a similar question in your activity. So that is the reason I can say that depending on the context and the way of thinking, I can say that this series of bits correspond to multiple things and all the things are correct. So it majorly depends on the context of information that we are trying to represent, right? So anyone has any more query related to this? And did I make myself clear about this, whatever I wanted to say here?
So just one quick doubt. You mentioned that the rightmost is least significant. That is only mathematically, or is it related to uh, uh, there not being a significant change if that bit is lost?
Yeah, so even in mathematically, how would you say that there is no significant change if that bit is lost? Even in mathematics, when we talk about coding and conversions, we'll talk about all the, we'll take all the places of the bit together. See, if when I say that this is 8-bit, I should consider they are 8-bit. Removing one bit from the right will make it 7-bit, and that will change the whole idea. So it is not, the significance is not in that sense. The significance is at the place value. So if had there been 1 in the last place, I would have raised that that place value would have been 0, and if and then I would have raised that to 2 to the power 0. So that would have added only 1 to my number, right? So if I go at move towards left, the more left I go, the more power it raises to 2, and then the more value it adds to my number. So that is making it more significant.
Okay, thank you, sir.
Hello, am I audible?
Yeah.
Hello. What if we have one more option like character A? Will that option be right or wrong? Because we can make our own encoding in which we pair A with this sequence of bits. So all of those options can also be right?
Correct. Yeah, so in that case you will be right unless you mention the context, right? So if the way you said to me that if I want my own encoding technique in which I want to represent this as A, so that is the information that you are providing along with these bits, right?
Yeah.
So in that case it will be correct. So that's what, if the information and the context is there, then it makes sense.
Okay.
Yeah, anyone would like to ask anything else related to this question? Maybe discuss anything else.
And I would also say that the people who gave option A, like the left one, second and third as the answer, they are not wrong. Okay. So it depends on what you thought at that point of time.
Shall we move to the next slide?
Yeah, I think. Yeah.
So again, I would request all of you to please refresh your screens and please click on the prompt, whatever is being presented on your screen, in order to come to this next question or slide. I would request each of you to please log on to menti.com and please enter the code if you have missed that. It's there on the top of the screen. 771447770. Others, shall we start the discussion for this question?
I think we can go ahead. Yeah. Okay, so I can see a lot of responses here. Okay, so encoding data with the minimum number of bits. Okay, yeah. Can be context based. Okay, so I've taken this from the previous question. Characters of a document occupying fewer number of bits. Okay. Space containing bits for each character. Okay, someone has given examples also. Is it tar? Okay, encoding efficiency means the fastest way to encode any data and secure it. Using different and more suitable way encoding mechanism to represent characters for data, file, etc. Okay. Okay, so some people have done good study on Hoffman encoding and Unicode also. So yeah, this is good number of responses, and also as all of them have given more or less right answers. Yeah. So okay. So there are things that I want to add here, and there are things that they are mostly said by one or the other of you. So yeah. So when we talk about encoding, what we do is we seem to say, okay, the major problem is to acquire maximum number of bits. Like our bit set should have or should cover all the number of bits. That is the reason we are increasing the number of bits that one character can have, right? So let's say when we talk about UCS4 or let's say ASCII 7-bit, so there are 7 bits to store the number, and in the UCS4 the characters are stored using 32 bits, right? So UCS4 is definitely by far very good encoding technique too, and that covers a large variety of characters expanding through the different languages, right? The future and the past and the present languages. So that can accommodate so many characters. That is not the case with the original 7-bit ASCII. But the problem is, when we talk about 7-bit, we talk about 32-bit, that is UCS4. Each character would take 32-bit. In case of UCS4, each character would take 32 bits to store, right? So in that case, if I want to store a document that is, let's say, 1,000 words, including spaces, let's say there are 1,000 words, or including all the spaces, and together they come up with, let's say, around 5,000 characters. So in that case, if I want to store this 500 characters with the help of UCS4, that is 32-bit per character, how many would it take? I guess 16K bits, right? 32 into 5,000. How much would it come? So 32 into 5,000. I would go with 1,60,000 bits, not even 16K, right? But if I go with same number of characters with the 7-bit ASCII encoding, that would go with only 35,000 bits. So in that case, I say that I may not be able to acquire or like encode all the different various characters there are there in the market, but I can reduce the size of my document. So there are various methods that we bring into account to do this, and efficiency here is specifically saving the memory. So the less is the space taken by our document, the more efficient is the encoding, right? So that is what is there. So is there anything that you would like to ask?
Anyone would like to explain their answer in detail than 150 characters here? So maybe you can unmute yourself and can give your thoughts.
Yeah, that is a good idea that we can do.
If we know beforehand what all the characters are in the document, then we can decide for sure which is the best encoder. I suppose there is this is my query. Suppose there is a document in which almost all the characters can be represented by, say, ASCII 7, but there are few characters which are not there in the ASCII 7, but which may be required to use UCS4. So, I mean, some Chinese character or something like that. So, how to go about that in those cases?
Yeah. So that's where we talk about encoding, right? So there has to be something compromise made between something that can accommodate more characters and something that takes less space, right? So as you said, let's say there are some characters that takes only 7, that can be accommodated within the 7 bits, and then there are some characters which might take more bits. So for that we have methods like Unicode, right? So where there we decide that okay, how many bits to be taken in left to be encoded, and how many bits are occupied by some type of information that is provided to how it is encoded. So that is where the terms like Hoffman encoding and Unicode comes into the picture. And like we will be explaining more on this with the help of an example. So till then, I would ask you to just
Others, shall I add a few more points here?
Yeah, sure.
Yeah. Okay, so yeah, it's quite possible. Means if you already know what types of different characters you want to have in your document, you could easily design your encoding scheme or Of course, you could decide the efficiency as well. But the thing is the standardization. The encoding that you are defining. Now, of course, if you're defining this, you might try to encode some document that you want to share across within your network. So the encoding that you have defined, the others who are getting those documents, will they be able to understand? Will they be able to decode that? That is the issue. And why we are taking these examples, maybe UTF-8 and UCS4, something like that, because they are always standardized. If you are encoding your document, let's say in UTF-8, the other side already know, okay, what this character means and how should I decode that. It's quite possible to create your own encoding scheme, but the standardization matters. How would you make it interpreted by the other people? Yeah, am I making sense? Whoever was asking the question.
Yes, definitely.
Yeah. Okay. Yes, anyone else would like to give your thoughts here?
So, what if we add our own like header, defining our own encoding style, and then the data of the original data with our own header, defining our own encoding, so we don't have to standardize everything. Is that possible? It will decrease the size of the file, and defining encoding won't take that much bits, right?
I didn't get the whole point that you are trying to make here. Can you?
Okay, so I was just saying, can we add like our own encoding style? Basically, there was original data, let's say document or a text file, and we are changing the encoding, and we are defining our own encoding on the top of the file.
Okay.
So basically, first the encoding definition, which encoding we are using.
Yes.
And then we have the whole text.
Yeah, definitely. So maybe if I take the specific example, let's say the HTML document itself. So there we used to define, what type of encoding we are using for the document. So we most probably use the UTF-8 encoding. We define it in the meta tag using inside the head tag. So yeah, that is a kind of standard. Means, of course, maybe if you will not put it by default, it would be UTF-8 only. But it's a good practice to do that.
Okay, and we can make our own encodings, right?
Definitely, it's
like,
quite
okay.
Possible.
Okay.
Yeah. So see, you can make your own encodings, and as you mentioned that there has to be some headers where the information like how your encoding is given, right? So so to convert that headers understandable to machine, how would you do that?
By defining, like, I think defining our own encoding won't take that much of bits, right? Because it just the pairing. We just only have to define one time, like, okay, this bit is paired with A, and that's the other one is with B, and so on. So we are not defining for like we have a big data, let's say 2 GB of text file. Then before that 2 GB of text file, we can just define our own encoding. Maybe like
So what you are suggesting is that you can reserve some of the bits stored to define your header, right?
Yeah.
And then the remaining bits can be used to store the data. So, see, that is the mechanism of Unicode. So that's why I mentioned. So what happens is some bits are reserved to show the encoding technique, and some of the bits are reserved to store the actual data. So what you're suggesting is happening in Unicode, and that is more standardized. So what you are saying that you can create your own encoding is definitely correct. And the way you want to give your headers, the information on your encoding should be given with the help of reserved bits. So that is it.
Okay.
Can I just add a little bit to that?
Yes, sure.
Yeah. So a couple of things. See, one is, in your question, Mohit, I think the way that I understood it was, let's say that you are coming up with a mapping where character A will be represented by some sequence of bits, character B will be represented by some sequence of bits. You are saying that all of those representations you will send as part of the header, correct? And then afterwards you will send the rest of the data, because anyway now the header is only like a one-time investment. Is that right?
Yeah. Yes.
Okay. So see, that is not usually what we do in things like UTF-8 and all, right? And UTF-8, I don't even need to do that, because both sides have already agreed beforehand that if I say UTF-8, I just have to mention that one line char set equal to UTF-8, and that is enough. The other side knows that this is going to be my encoding. Okay, so I don't even have that header that I need to send. I just need to send like some 10 bytes or something. Okay, that is when the encoding has been sort of pre-agreed between both sides. Now, in your case, what you are saying that you will send the header information each time, that will work only if you are sending thousands or millions of bytes, because otherwise, even for let's say just if you have like 30 or 40 different characters, you might find that at least like few hundred bits are required in order to give that initial header information. So let's say that it takes few hundred bits for this, and then you have like a few only like some 100 bytes or maybe even 1000 bytes. That is still like at least like 1%, 5% of your total data might go in the header. Okay, so unless you are transmitting enough information, you won't benefit from this, right? But just to add to that, actually what you said, right, that you will create your own encoding and send it, is exactly what is happening in a program like zip, for example, right? So when you do a zip encoding, effectively what that compression is doing is that it first goes through your file, it creates an encoding saying that for this file, these kind of sequences of bits are sort of found very often. I will use some other encoding for this sequence of bits, which uses less space. And what the file, the .zip file that you create effectively has is exactly what you said. It will have one header which contains a dictionary saying that this bit or this sequence of bits corresponds to this other sequence of bits. So when I try to read that zip file, what I should do is first read the dictionary, then go read the actual text and replace each part of the data with the unpacked thing. Okay. And if you look at it that way, zip is actually much more efficient than any encoding that, well, not much more efficient, but it is a very simple and neutral way of creating such a thing, which does not depend on having to create these kind of encodings ahead of time. Okay, so I hope that answers your question, right? I mean, it's just basically an addition to what you said.
Yeah, yes, sir. Thank you for the input, sir. Thanks.
So suppose I know that I want to encode only numbers, only integers. Is it possible to achieve this with 4 bits, including the header?
So, I mean, see, the header will always take up some space if your encoding is non-standard, right? I mean, see, the whole point is this. Let's say that you are talking to somebody else. If the other person also knows what your encoding is, if you have both decided ahead of time that, if this sequence 1010 corresponds to number 10, right? Then there is no issue. You can just send the sequence of bits and the other side knows exactly what it is and, will read it off that way. Okay. But if you have not agreed ahead of time, then you have to spend some, you have to basically encode the transformation in some way. And that will take up space in your overall packet of data that you are trying to send. That's all. So in principle, so if you look at it, for example, right, there is something called the .wav format, which is used for audio files and generally for storing, mostly audio, right? Now that .wav format is actually a very simple format. It has a very small header. It just has something which says this is a .wav format, and it says something about the sampling rate. But that's it. After that, what it says is all the data is 16 bits at a time, and these are just 16-bit numbers. Okay. So then the reason why this works is because both sides, the other side which is receiving the .wav file, also knows that after seeing that header, it has interpreted, okay, this is .wav. So read those few initial bytes for the header. After that, every, let's say 16 bits is treated as one 16-bit number. Or if it's like 8-bit audio, then every 8 bits will be treated as one number and you proceed. You could even in principle say that, I want only 4 bits and define a new format like that. Nothing fundamentally preventing you. It's just that, both sides have to agree. Otherwise, they won't understand what the other is saying. That's all.
Thank you, sir. So it's basically like a protocol.
Exactly. Right. I mean, any protocol, all these formats, encodings, protocols, all of them work only because both sides have agreed to interpret them in the same way. Right. So even all this UTF-8, ASCII, all of those things need to be understood as that. They are encodings. All that the encoding is saying is both sides have pre-agreed on some particular way of representing data. Right. And that's why it works. That's basically it.
Thank you, sir.
So anyone has any other query here with respect to this thing? Seems to be clear. Others, shall we move to the next slide then?
Yeah, we can.
So again, I would request you all to please refresh your screens in case you have logged out from the menti.com. The code is present here on the top of the screen. You could use that code again. I would request you use this code in order to answer. Please participate in the discussion that is happening here in the session. This would be beneficial for you. Others, shall we move ahead or shall we wait for few
Yeah,
more
so if
seconds?
anyone is typing, just we can wait for 1 more minute and then we'll go ahead. Yeah. So yeah, I think now we can go ahead. We have enough responses. Yeah, okay. So procedure is all about looks and descriptive about meaning. So this is a very concise way of putting it. In procedural markup, you specify exactly how the text should appear. Example, bold. Okay. Procedural details on how to display, while descriptive markup takes consideration the meaning of the text. Okay, so like, can you move downwards? Okay, so the more or less everyone is saying the same, that procedural is the way it should be displayed, and the descriptive markup focuses on the meaning, right? So this is pretty much correct. And the thing is, the procedural markup, we give some procedure, okay, how to show a particular text, right? If I want a particular statement to appear as a heading, I would give it, okay, increase the font size and make it bold and keep it at the center. So these are some procedure, these are some guidelines that I'm giving to that particular text so that it appears as a heading, right? But in the descriptive markup, I particularly give the description of each of the text that I'm trying to give in the main document. Okay, in the descriptive markup, when I say, okay, so let's start with procedural markup. So so as I mentioned, that when we want a particular thing to appear as a heading, and we say that for a particular thing to appear as heading, we want it to be a couple of more font size. It should be bold and it should appear center. But that is the procedure. Okay, that is the procedure that we define to keep it as a title or the heading. If I want to access the same document after some time, let's say couple of years, and then I came back and then I saw, okay, I want to figure out what are all the headings. I also need to recall what procedure I gave to uh, keep a particular statement or a particular sentence as a heading, right? I need to recall that, okay, that sentence kept as heading had been given 2 extra pixels for the font size. It was given bold and it was taken center. So I need to manually do that. But that is by itself done in the descriptive markup, right? As soon as I put something as heading in the descriptive markup, it will be kept as heading. And I can very well change the appearance of it with the help of styling later on, right? So I need not worry about how it looks in the actual sense. As far as HTML is concerned, I will just mark it up that this particular thing is heading in context of descriptive marking, right? So I'll just mark it up. Okay, this is the heading, and then it completely depends on me how I want that heading to look like, and that the complete thing can be given with the help of can be given externally with the help of styling, right? And again, okay, this also solves the problem of finding it later on. So if I want to come back to the document and see, okay, what are the headings that I've given, I need not recall what presentation or what styling I had given, right? I will simply go towards, okay, what are the headings? Okay, these are the headings. And then I can move on to, okay, this was the styling given to my heading. So in that sense, descriptive markup is very beneficial, right? So what it does is it also gives me, and with that, it also gives me a complete freedom to use multiple presentation for same kind of thing. In that is, when I want to access it later on, I can change. Okay, I don't want now the heading to look like this. I want the heading to look like that. So I can change simply the styling, and I need not remember that. So that is one of the major advantages of descriptive markup over the procedural one. And this with that, it also makes my document more interactive, right? I know what is what, because I have specified the meaning of each and every tag, as you have mentioned in one of the answers. So I think this is a pretty clear explanation. If anything you want to add, Abhishek, would you like to, or is it fine? Or anyone else wants to add anything?
Yeah, that's fine. So I would encourage the others to express
Yeah,
their thoughts
yeah,
here.
sure.
But
Anything else that you feel, okay, descriptive markup can also be used or can also be advantageous over procedural markup in this way? You felt that while making your HTML document or something like that?
Aside to this, can we take example of say presentational markup and procedural markup? I mean, if we can show it through an example, that will help me understand it much better.
Yeah, sure. So you want me to say it, or with the examples to be said or written?
Written.
Okay, Abhishek, we might want to.
okay, so yeah, I would just try to give you some scenarios how you could differentiate between them. So presentation actually works on the Wysiwyg principle. What does it mean is what you see is what you get. That means whatever you are typing on the maybe wherever you are typing it, and whenever you will take a printout of whatever you have just typed, you
Yes,
will.
MS Word is that. Correct?
Yeah, in some sense, you could consider MS Word as an example of a presentational markup. Okay. Now, if we are talking about the procedural, so procedural will go into the details. It will try to provide all of the instructions. That see here, if we talk about the procedural and the interpreter that we are talking about, which will actually interpret what you have written and how should it be interpreted. It needs to be less intelligent. Why? Because you are providing each and every detail. See, you are saying, okay, I want to maybe give this much of space. I want to shift to the next line. I want to do this. I want to do this. Maybe if you are aware of some maybe assembly level languages, maybe you would have studied something about microprocessors. So there, if you are writing some assembly language programs, so you will have to specify each and everything. So you use some registers there. For example, you want to store a particular value at a particular place. So firstly, you have to specify that thing in a line. In the next line, you will have to specify where you want to store the second value. After that, you have to specify.
I'm sorry to interrupt. I have not studied anything earlier. If you can show me through an example.
Okay, maybe currently we won't be able to show you. Maybe we could just explain you that it would just go into the details. It will try to provide you some instructions, maybe some algorithm type of thing.
Let me just I mean, I can try and address this a little bit. See, first thing I would say is I don't think you should be too concerned about the differences, right? I mean, this is one of those cases where it is less important to be able to say this is presentational markup versus markup versus this is semantic markup versus this is procedural and so on. And more important to sort of understand why different modes and what are the benefits and drawbacks of different modes. Okay, so why are these terms even there, presentational, procedural, and so on? That's partly because of an early study of markup languages, right, which basically allowed this, I mean, where they tried to sort of come up with what are the different ways in which you can look at markup languages. Okay, so I can do one thing, Abhishek, maybe I can just share the screen briefly from my side. Okay, can you, I think you might, yeah, let me just share. Oh, okay, I can't screen share. I'm not sure if you need to. I think I'm showing up as a participant over here.
Okay.
Or I can.
Vignesh sir, can you please make Nitin sir the host?
It's okay. What I can do is I'll just paste this link over there. If you can open it, I think that's also fine. Okay. So see what this web page has, right, which I've just posted the link for, is just actually one snippet from the original 1987 paper, which sort of went into so-called taxonomy of markup, right? So there you can see that under that second heading, taxonomy of markup, it says there are 3 categories of electronic markup: presentational, procedural, and descriptive. And that Coombs et al. 1987 is referring to the paper where they actually came up with this taxonomy, right? And taxonomy is just sort of a way of giving names to things so that we can sort of try and understand them better. Okay. Now, the problem is, you can imagine, right? This is 1987. They are trying to sort of make sense of markup, which was studied in various forms up to that point, but is not so extensively used to the extent that it is now. I mean, for example, HTML itself didn't exist at that point, right? But if you go down a little bit, scroll down a little. Yeah, so this part of it, right? I mean, so I think this picture, yeah, you can just leave it as it is. This picture is a good way of sort of showing all the different ways by which you have markup. So at the top of the screen, right, I mean, this random set of characters which you can see, if you look at it closely, you will realize that it is actually all the same words which are there in the next paragraph also in the under the presentation. It's just that all the spaces have been removed, the punctuation has been removed, everything has been taken out, and only the characters are there, right? And that is what they call the no markup default. Okay. And then what they say is, okay, let's go down to the next one, which is presentational markup. In presentational markup, I have actually done all the formatting. I say the first line basically says Milton expresses this idea. It has a colon. After that, leave blank 2 blank spaces. Now, this is what it would look like in a word processor like MS Word or Google Docs writer or something of that sort, right? Where basically, how does it know that it needs to leave 2 blank lines after that word tracked? There is some character which is there inside the file which tells it to leave 2 blank lines, but we don't see that character on the screen. Okay, we know that it is some kind of a new line character. It must be there somewhere inside the file, but it's not displayed. It is just there. So the presentation part of it has already been taken up by the way that the thing is displayed on the screen. Okay, so that is an example of what you would see in Microsoft Word or Google Docs writer. Okay, now
So basically, while
yeah,
we are typing in MS Word,
yeah,
after a sentence, if I'm entering, doing double enter,
correct.
That is kind of giving the instruction that the 2 lines have to be
exactly
given.
So you need to leave 2 blank lines over there. You are giving the instruction to the word processor, right? On screen, it shows up correctly, but the fact that you press those 2 enter characters is not actually displayed on the screen. I mean, it's displayed in a different format. It is displayed as a blank line, not as a 1 enter character. But if you go and open the file,
but that is a user input.
Sorry, what is that?
I mean, that is what I enter. I mean, I pressed the enter button twice. That is why 2 new lines came up.
Yes. So presentational is also definitely controlled by the user. The fact that you pressed enter twice is fed into the document. The document has those 2, whatever ASCII code 0A or whatever it is, those 2 characters are stored inside. But when it shows it to you on the screen, it shows it in a different format. It doesn't show those characters that you typed in.
Okay.
Okay. Now contrast that with procedural. In procedural, now let's look at exactly that same part, the word which comes after tracked. Okay. Now this language that is shown over there is some kind of one of the earlier word processing languages. It is similar to LaTeX, but I believe they are using NROF or something of that sort, which is used for formatting documents in Unix, right? And over there, that .sk3, for example, is, that .sk3 in plus 10 minus 10, all of those are literally saying from this point, skip 3 pixels or skip 3 lines, then go indent by so much. CP2 is, I think, basically 2 blank lines or something of that sort, right? I don't even know what that language is, so I'm sort of guessing over here. Okay, but you can see that .in plus 10 is used to indent inwards by 10. And if you go down to the bottom after that dust and heat, you will see that there is an indent minus 10. So it basically comes back out. Okay, so In other words, what this procedural markup is doing is it is telling you the steps, the algorithm to be followed in order to get the result which came in presentational markup. Both of them will finally result in the same appearance. Okay, but the presentational markup just has that enter character, which the word processor knows needs to be shown in this way. In procedural markup, it gives you a detailed set of instructions saying do this, move by so much, move in by so much, then start printing characters and so on. Does that help to understand the difference between presentational and
Yes.
procedural?
So
yeah.
So what I understand is like see the output on the screen for both presentational and procedural will be the same.
Correct.
Just is that presentational, like in MS Word, I'm typing as it is, and which is coming output on the screen as displayed. In procedural, it will go through the file, this file, which all the instructions will go through the processor.
Exactly.
And the output, the processor will understand the meaning of the extra instructions and then output as per the, say, presentational itself.
Exactly. Right. And now the last part of that is if you go down to descriptive. Okay. Now in descriptive, if you look at it, it is very similar to procedural because here also we don't have that indentation and so on automatically done. Right. Instead of that, you can see that there is one LQ and one /LQ. Okay. Now what is that LQ for? It's basically to show that whatever follows is a quote. It's some kind of quotation. So that LQ is basically some kind of a quotation mark equivalent, right? Now in HTML, this would be sort of shown by the open angle bracket and QOTE. And again, similarly, there would be a /QOTE, right? Which you could be used for the same thing. Now, what will happen in this kind of descriptive markup is that just like in the case of procedural, once again, you need either a compiler or some kind of a program which is able to read those procedural markup and say, okay, now this is what quote means. It means that I need to indent all the remaining text by, let's say, 10 pixels or whatever, and maybe use a different font, different color, something like that, and place it over here. HTML and LaTeX and so on fall in this category. They are descriptive. They are telling you something about the meaning of what is being written and not about how it should be shown. The how it should be shown is determined by the browser in the case of HTML or the LaTeX compiler in the case of LaTeX documents which are converted into PDF. Okay. So nowadays, most of these markup that we would like to do, especially HTML and so on, falls completely in the descriptive class. Descriptive is, in some ways, it is better than presentational because in presentational, if you go back and look at it, there was nothing which you can look at it and understand that, the fact that it is indented, okay, when you read it, it looks all right. But let's say that, it is being parsed by a computer and the computer is trying to extract information from it. It doesn't know that that was a quote. It just sees that something is indented. What is it supposed to infer from that? It can't automatically understand that that's meant to be a quotation. Okay. So descriptive is the class into which HTML and similar languages fall. Procedural is, it's somewhere in between presentational and descriptive. And in fact, you won't really find too much procedural markup now anywhere. Okay. So does this help to clarify?
Thanks a lot.
Yeah. Okay.
Thank you so much. So I guess this has been discussed in much details. I guess we can move to the next slide.
Yeah.
So the question is difference between block and inline HTML elements. Request you all to please refresh your screens and again do the same thing that you did before. Yeah, so I would request you all to please give your responses here. We have just got 4 responses till now. Request all of you to please log on to menti.com, use the code mentioned on the top of the screen. Please participate in the discussion. Okay, we have got 9 responses. I will just wait for maybe 1 more minute. Okay, 10. Okay, so Adarsh, would you like to open up the discussion now? We have got 11 responses.
Yeah.
Yeah, are you able to
Okay.
see the responses?
Yeah, sure. So the block is div when line is span. Okay, correct. So these are very traditional examples of block and inline elements, that these tags div and span. Span and other inline elements can be used within more number of elements in the DOM tree. Div and block elements are basically larger containers. Okay. In block, we can add more block and inline elements, HTML elements, but we can't add them in inline HTML elements. Okay, so this is generally what we see. Okay, it is the same as the difference between a bus and a cycle. Okay. So why? So are you trying to say about the size with this? So and what is what? What corresponds to what? Bus corresponds to block or inline? Okay, I'm not asking. I'm just reading out.
Yeah, well, that's an interesting response. Anyone who has given this response would
Yeah,
like to
yeah,
unmute and
definitely.
clarify.
Block can contain many inline, but reverse is not true. Okay. Okay. So okay, these are very good responses, which covers a lot many differences between the block and inline elements. But okay, so I like to add some more. First of all, see I've seen this twice. The block can contain many inline, but reverse is not true. See, this is not like the completely true statements. Obviously, yeah. What we have seen is adding an inline element in the block mostly, but it is quite possible to do that. Only that your presentation will not look good. See, HTML is when you render this, it will be rendered. It will not be showing any error to you. So this is definitely possible. In some cases, it depends on what type of styling we're giving, right? So as you can see, the responses have borders here, right? So if there is a border in both the block and inline element, and if I try to put an inline element, a block element in the inline element, the rendering of that particular document would not look that good. But it is not possible. It is not true that it will not happen. Okay. So that nesting both is true. It depends on how we look at it. What looks better to our eyes when it is rendered. So, and what is the general trend? So mostly all the inline elements are nested within block elements. That is what we see. Okay. One again, a major difference is that which nobody pointed out is block element takes the entire part of the screen, right, horizontally. Or I have not read it. So I'm sorry if I have not read it and mentioned that. But
As a response, I guess at last.
okay.
But trying to mention.
Okay. A block level element has a top and a bottom margin, whereas an inline element does not. Block level element always starts on a new line. An inline element does not start on a new line. Okay, it does not start on a new line if there is space on the right. Okay, so you kept on adding new inline elements, and there's a point where you reach at the last of the screen. What will happen then? Okay, so you should give this a try. Okay, add 7 to 8 multiple inline elements and see what will happen if the last element goes. If the last element or the space that the last element is taking goes beyond your screen, what will happen then? Okay, you should give it a try. So yeah, so the block elements take the complete horizontal part of your screen, whereas the inline elements, they only take that much part which is required by the text within them, right? And some what we say, some margins, not particularly margin. I should not mention margin here, but some space that is confined to particular character. Okay, that is given to particular character. So that is one major difference. Second difference is whenever you write a block element, a new block element would take a new line. Okay, that is not true always for an inline element. So that is one major difference. There are several other differences. Let's say what happens when I want to add a width to an inline element. Okay, see, when I say that an inline element takes up only that much space as what is required for its content, what happens if I provided it a width, extra width? What will happen then? Will it take that width or will it not? Okay, so that is one question, and which is very much possible for the block element, right? So when I say that a block element takes the complete width of the screen, it does not depend on what content it has within it, right? So my content may not be taking the entire space of the screen, but my block element would. Okay, so if I want to add something beside my block element towards the right, that is not possible if my block element is taking the entire width. Okay, that will be possible if I try to reduce the size of that block element so that it does not take the entire space. So what I'm saying here, what I'm trying to say here is that the block element can be given width, which is not possible for inline element, right? So this is one of the major differences. Okay, can we talk about some other differences? Okay, can we talk about some special cases? Let's say if I want to put a block element that does not take up the entire space, as I mentioned earlier, that can the width be decreased? And is it possible to put two block elements side by side? Right, so we are saying that inline elements can be put side by side. They won't take a new line unless we ask them to, or unless we put something to that to break the line. So can we put two block elements? So that is, let's say we are not going to that detail now. That functionality or that appearance can be brought definitely, because that is what we do there. We take some of the good properties of inline elements and give it to block elements, right? So that is something like that. So there are various differences between the block and inline element, which somewhere helps us in making our presentation or our presentation better. Okay, now see, there are more things that I can talk on, but everything to put at one place would not be a good idea. But there is one interesting thing that I would like to go is that response that is given earlier, right? So there is a difference. The difference is equal to the difference between a bus and a cycle. Okay, so whoever gave that response, would you please unmute and explain that? Abhishek?
Yeah, okay. So people are suggesting to use the whiteboard. Maybe I can open one. I hope this paint screen is visible to all.
Yes.
Okay. So if we are talking about some block level elements, so suppose I have one block element here. Let me just create the boundary of the page. So this is my boundary. Suppose this is one of my block element and this is one of my block element. So what Adarsh was trying to ask here, that is it possible to do that? As we already have mentioned that the block element would take the whole width horizontally. Means this should consider the width till here. But is it possible to place one more block level element adjacent to that? This is the question. Is it possible to maybe convert a block level element into an inline in some way? That might be a question to be asked in maybe a slightly different.
We can use style width, the percentage 20% or 30%.
Okay. Okay. So I am not sure, but means we are just doing it on a high level. This session is mainly being focused on discussing the activity and practice questions, but still we're just trying to give you a high level view that how this can be done. So actually there's a CSS attribute called display. So if you could change the by default nature of a block level element to, let's say, inline block. Now what this will do is this will convert a block level element into an inline. And what does an inline element do? It will only take the width as required, as much required. That means if it requires that much width, it won't cover the remaining space from the page or from that particular line. The same thing can be done with an inline element also. If you want to change the CSS property of an inline element to a block level element, this can also be done. So in that case, the inline element will start taking the whole space. Doesn't matter what the size of the text is. Are you able to get this point?
So if we change the default settings, then both will be the same, this block and inline.
If you will change the default setting, both will, yeah, we can make them behave the other way. This could be done, but of course, by default properties are somewhat different. But you could, of course, play with those properties and try to, alter those properties and come up with a different type of.
If I alter, then will there still be any difference, or they will be the same thing?
Yeah, it will just inherit all of the properties from that inline type of element. Yeah, it will work. It will behave same as that of inline.
So is it like inline is a corollary of block, or vice versa?
Sorry, inline is a. I didn't get your point.
I mean, from block itself we can do inline, or from inline we can do block.
Yeah, it's possible. It's possible. Yeah.
Yeah, so the point of saying this is by block we can do inline is what we are trying is there are some properties that block level elements follow, right? And we are trying to acquire some properties, some required properties from the inline elements and giving it to block. Okay, so with this statement, this display, we do that, right? But the thing is, we should the main focus is to keep the block elements differently inline elements differently. So keep differently as in to take their properties differently, treat their properties differently. And if you want each of their property to come come in the other, we use display. Okay, so display what it does, it mixes the property. Okay, and by the term mixes, what it does is it acquires the required property. Okay, so maybe this is not very clear now, but the main focus is to keep to first understand what is the block level elements, what are the properties of block level elements, and what are inline elements, and what are the properties of inline elements. Once that are understood, like we should know what they can do, we should know what they can't do, so that the things they can't do can be acquired from the other element that they can do. So is it clear?
Yes, thank you.
Okay, for now, it is imperative to know that the block elements take up the entire space, the horizontal space. Okay, and the inline elements, what they do is they take up only that much space which is there in the content, which is taken by the content within the inline element. Okay, whenever I want to start a new block element, when I want two blocks element to come, two blocks element in the text, when I want to add that, they will come in the new line. Okay, one block element below the other. Unless I have some special properties, I cannot make two block in the same line. Okay, and if someone mentioned that, someone has before mentioned that we can, okay, change the width and say 15%, 20% like that, right? So we, in that case, the width of the block element will definitely reduce, but it will still not allow any inline element or any other block element to come in towards its right. So that will not be allowed by the block element. Okay. Similarly, for an inline element, if I want to add some external width, because we are mentioning that the width taken by that particular inline element will be according to the content within that element, right? So if I try to add some width, that won't be possible very easily. So this is some deficiency of inline element. There is some deficiency of block element. So to cover to make inline and block elements complementary to each other, covering each other's deficiency, we will use display. Okay, so we'll get into that more detail in the coming sessions. But I hope basic inline and block elements are clear here.
Yeah, so the by default difference is that a block element will always take the whole width explained in the horizontal plane, whereas an inline element will only take as much as width as required by the text or by the content of
Yeah,
that element.
it's like sentence, writing a sentence after the sentence within the same para is like inline, and writing different paragraphs are like block.
Yeah, you could say, yes. Yes, okay. So for example, you want to, let's say,
okay, yeah, sure. Go on, Abhishek.
Yeah, suppose you want to display two big names, like maybe in big fonts or something like that. But what you want is you want both of these names to be displayed in in the different lines. Now, of course, there are number of ways to do that. Maybe you could put all of those names in a span tag. So span is an example of inline tag. But in order to make it cover the whole width, whole X plane horizontal width, you could change the property of that span element, that CSS display property, to block. What will it do is it will make that whole name cover the complete width in that particular line. And the next name that you have specified will automatically come in through the next line. Maybe we'll get into more of these details as others mentioned in the coming sessions. Means if this topic has been triggered, so let me just announce this thing as well. So in the week 1, we had 3 sessions. One session was all about activity questions. The second session was all about practice and some other discussions. The third one was the open session or the summary. Now from week 2 onwards, what we are planning to have is the first session that is happening here today. That means on the Wednesdays. This session will primarily be for discussing the activity and practice questions, and the session that is used to happen on the Fridays. So that will be a solve with us or solve with instructor session. There we will try to do the programming part of this course as much as possible. We'll try to use the Rapplet as the tool in order to demonstrate each and everything. So whatever things that we are discussing today, maybe we'll be doing these things in the coming session on Friday. So I would encourage all of the students. I would strongly recommend, especially the absolute beginners who are new to this HTML and CSS thing, please attend those sessions, solve with instructor sessions. They are going to be very beneficial for you. So this will that session will completely be this programming oriented. We'll be using the Rapplet as a tool. So before coming to that session, we would expect that you will gain some working maybe a small familiarity with the Rapplet tool. I guess some tutorial videos have been provided on how to develop some familiarity with the Rapplet. So maybe I would request all of you to please watch that video. I guess that was a part of the week 1 content. The title of the video was Application Development Using Rapplet. So request all of you to please watch that video before coming into the next session. That would actually be more beneficial for you. Yeah, is it okay? Was I audible, Adarsh?
Yes, yes.
Yeah.
Message was clear.
Okay. Okay, thanks. So I would strongly recommend each one of you to please come into that session. We'll be seeing so many different kind of things. Of course, we'll try to start with some of the very basics thing, but of course we'll try to pitch in some kind of relatively some difficult or maybe some tricky things also.
Today, what I saw that even if suppose localhost server is running for long, then even if I make changes in the style.css file, it is the page is loading from the cache itself, and it's not reflecting the changes made every time I'm doing that. So I had to clear the cache and then reload the page. Then it started working again. Fine.
Which server are you using?
No, that the same localhost Python 3.
No. Which server? HTTP server or
Python 3 HTTP server.
Okay. Python 3 HTTP.
No, I just wanted to share this if anybody might encounter the same problem. What I did, I had to clear the cache and then it started working properly.
Okay, yeah, means I'm happy you raised this up here. So I just wanted to add one more thing, that server that we are using for these initial weeks, for the first couple of weeks, HTTP server, this is capable of handling the static web pages. Maybe, yeah, of course, you cannot do something fancy there. Maybe try to develop some dynamic web pages. So it might happen in some cases, but of course it's not recommended, and maybe HTTP server will not allow those things. So in the coming weeks, we'll be learning about the Python-based web framework Flask. Then we'll start developing some dynamic web pages. But for the initial weeks, when we want to serve our HTML documents that we have prepared with our friends or maybe with some anyone amongst different people on a local network. So that's why we have just introduced this concept of server, so that you can get to know, okay, that whatever HTML pages you have prepared, whatever website you have, that can be shared with others also. So that please use that only for creating static web pages.
Hi sir, one question is there.
Yeah.
What's the difference between the starting the server, because that we have a static website with 5-6 HTML pages directly also I can open in the web browser, and
Yes,
it will work fine if it is the save in the same folder.
Yes, yeah.
So what's the difference mainly between to start the Python 3 HTTP server?
If you are serving those HTML files using server, you will be able to share those files on a local network. It means if suppose your laptop or your mobile is connected to the same network or maybe the same router, you could just hit the IP address of your computer. You will be able to access that website in your mobile.
Okay, got it. And one more question, sir. What's the main difference between the physical and the logical tag?
Between
the physical level of the element tag and the logical level of the.
So I would just try to make you understand with the help of an example. Also, I guess this was mentioned in the lecture also. I guess sir
Yes, yes.
took the example of I guess B tag and a strong tag. Like if please
Okay.
correct me if I am wrong.
Yeah.
So see, B tag, we know what does B mean. B is a physical tag that will always be used in order to make some of the text bold, right?
Yes.
Can you interpret something out of it other than that?
Bold from the B.
Yeah, B tag.
The EM tag?
No, I'm just
EM.
talking about B. Let's just keep it simple. Let's talk about only B. We'll move to those logical tags later.
Okay, so what's question actually, sir?
Yeah, I'm just trying to make you understand what the difference between what is the difference between a physical and a logical tag.
Yes.
So physical won't tell you about the meaning, right? It will just tell you about the presentation, how it should be displayed. But if you are going into the logical tag, that actually tells you much more about it.
Okay.
Now, if you are using a strong tag, so see, strong will by default, of course, it will also make the text bold. It won't do anything else for you. But when you are going through the raw HTML document, that would actually make more sense, because with the help of strong, you might not be only trying to make some text bold. You might be trying to highlight the text in some other way.
Okay.
So strong basically gives more details about the meaning. And the physical tag will only tell you about the presentation.
So the many questions raised here. So actually, it is the good when I'm crawling the reading. I'm going through the backside of the code through the HTML code. Then only can I understand. But the user who is seeing the outside front side, they will not able to distinguish. Isn't it?
Yes, it won't be. Yeah, of course. Means we are using in context of the user who is reading the document.
So they will not able to understand which is important, which has that.
Of course, means
because
if you are seeing the final output, that you can't differentiate between them.
Okay, so it is only good when someone is crawling the web.
Yeah. So when you are going through that exact HTML document, right? So suppose.
So what is the what's the mainly purpose of that for the Google crawling or the sub company who is crawling the website for them, or what's main purpose for our?
No, that actually depends.
Can I add to this?
Yeah, sure.
See, so when you talk about something that is presenting that the main document into bold, right? So you're saying that there is a tag, a physical tag and the logical tag, and both are doing the same thing, right?
Yes.
As a presentation. So for a viewer, there is not making any difference. But here we are assuming that the viewer is very, the viewer is normal. That is, he is not visually impaired. Let's say I talk about a person who is visually impaired and cannot differentiate between a bold and normal text. Okay, so the physical tag, which has the functionality to only make bold and nothing else, will not be and what did we use it for? To emphasize something, right? To make a particular part of the statement bold. And a physical person who physically impaired person who cannot make out this difference, will there be any use? No, right?
No.
But if I use a logical tag, let's say emphasize, I can style that emphasize tag such that with the help of, let's say, color, or let's say it's indentation, it's slanting, right? So that is making it different from the original text, which you as a normal person can read and which the visually impaired person can also read.
So actually the physical and the logical tag by default it's coming with HTML. I can't make anything.
Yeah. See, even you can do that. If it gives you the freedom to add external some more styling to that. The emphasize always wouldn't mean make it bold.
So other person how will know that it is the physically appeared or that it is the meaning is important? Suppose I use that some normal tag I have used. Suppose span I use and I made the color of the headline.
Okay.
So how will someone will come to know that it is only for designing purpose, is same as the bold, or it is the something is meaning is here, like the strong meaning is important. So
Yeah,
suppose
see, when
instead, yeah,
yeah, see, when a tag, when you talk about emphasizing and when you talk about strong,
yes,
strong will make it bold.
yes, and bold is also making bold.
Yeah, and that will also make it. Where can you add styling? In which tag can you add styling?
Yes. Oh,
Right?
styling means suppose I am using the third tag, which is the something span, or the something div or span, or the paragraph tag, and I'm writing some content between them, one word, and I'm making same as that some a special color or the something italic bold I can making. So it doesn't make anything like the logical.
Well, I wouldn't use div or span tag to make a certain part of text uh, different from others,
Yes.
right?
So I'm just asking that there is a nothing physical and logical here. We can distinguish only the physical and logical by default coming from HTML, or I can make like the title is a physical or logical tag. So
See, what you should keep in mind is physical
okay,
tags. Whatever physical tag styling come with default with HTML, that cannot be changed. Okay, if
okay,
a
yes,
tag makes it bold, it will make it bold. A logical
okay,
tag is something that you can define how it should represent.
okay,
Okay, so if I want my document to be read by all sort of people, normal, physically, visually impaired, and a person, as I mentioned before, if a person is visually impaired, okay, and cannot discriminate between normal text or bold text, will strong tag help here? It will not, right?
yes,
Whereas if I have a logical tag whose styling I can decide, and I know that, okay, a person cannot discriminate between the bold and not bold text, but he can discriminate between slanting, or he can discriminate between a red and black text. So in that case, I can highlight with that particular part with the help of logical tag. And the
okay,
physical tag was not helping me there, because my idea to make that particular part of document highlighted to him is not working there, because he cannot discriminate that.
okay.
Okay, so am I making you clear here or confusing you?
Somehow I am getting not that. I think actually I'm not getting the main content. The thing.
Okay,
I will.
what I would suggest is you can go through more examples over the web, and then maybe if there is a confusion, you can definitely
Can you give me the some example of the both the e- except from that strong and bold?
Yeah, there is one more called italic, right? Italic and the emphasized tag.
This is the logical.
Yeah, so the emphasized will be the logical tag, and italic it will be the physical tag. But both will actually, but how will they render the output? They will simply make the text look italic. That's it.
Okay. Okay, I will get try to understand this.
Okay, so unless you add anything else, see, there is no provision to change how a physical tag would render, or would bring the presentation, right? There is no way you can do that. But in
Okay.
physical tag, I suppose you can do that. So you can define your emphasizing, whereas in italic, it will be italic. You cannot do anything.
Okay.
So this
Okay,
would
see,
make more sense when we are going through the raw HTML document. Maybe you won't be able to differentiate when you are seeing the actual output rendered by the browser. That may not be differentiated. This can only be interpreted if you are going through that raw HTML document. And of course, since HTML is considered as a descriptive markup, so you could read through that, right?
Yes.
So it makes more sense when you are reading that document. So as we discussed some of the examples, physical text will only tell you about the appearance,
Okay.
while the logical tag will tell you, okay, this should be given some more importance than the other text. Now you could also style that tag. Maybe suppose you have kept some text in the strong tag. Now later on you could put some styling with the help of CSS for that strong tag, right?
Okay, the one thing also, logical tag we can modify it, but the physical tag we can't modify it.
I didn't get your point, sorry.
Logical tag we can modify it with the CSS styling.
Okay.
And physical tag we can't.
Modify, sorry.
The meaning is that, you know, you told that a strong tag we can change the color, everything.
Okay, yeah, we can apply CSS. Okay, that's what you are saying?
Yes. We can apply CSS in the logical, and the physical we can't. Like that bold we can't do anything.
Yes, it actually depends on the user, right? How you want to style your what we say, the logical tag.
Okay, so there is no particular fixed thing I can't do with that physical and can do with that logical. There is no such type of thing. We can manipulate both things any way we want. Like we can change the color of the bold and the as well as the strong also.
Yes, you could do that. Yeah.
Okay. I think very minute difference both are containing. That's why it's confusion.
Okay.
Yeah, okay, sir.
By the way, am I audible to all? Looks like your voice is breaking for me.
You are audible, Abhishek, and even both the conversations were audible. I don't know who was speaking now, so that person was also audible.
Okay, yeah, so we have got one request in the chat. I guess we could continue with the slides, but I guess most of the people are waiting for the conversion part, how to convert Unicode code point into the UTF representation. So others, shall we do that first?
Yeah, I guess we can do that first.
Okay, can someone tell me the code point? What was the code point? It was 543A9.
I also didn't understand what is this U plus.
Yeah, this is just a prefix. Okay, sorry, I guess I have written something wrong. This is just a way that how a Unicode code point should be represented. So U plus is just a prefix.
I mean, it doesn't have any initial value, kind of zero or anything.
No, nothing. So 54839, this is the code point, right? You may put U plus if you want. That is how you represent a code point actually in real. Okay, so now, as you know, that all of these characters are represented in the hexadecimal. And I hope you know how to convert a hexadecimal character into a binary. Okay, thanks.
Yes.
Yeah. So how could we do that? If we want to represent 9 into the binary, remember we will be using only 4 bits for each hexadecimal character. How could we represent 9? 1 0
1 0 0 1.
All right, this is how we represent 9. And how do we represent 3? 1 1 0 0. Is it correct?
Yes, sir.
Okay. So this will make the 39, that is 39, right? The last 2 digits. Now let's come to the later 2 digits.
Suppose I want to tell the representation of 3. So should I read it like 1100 or 0011?
Yeah, you should read it 0011 like this from left to right. So this is how we actually, when you convert a hexadecimal into decimal, so you start with, 2 power 0 into whatever the number is, 2 power 1. So that makes it more easier for us in order to convert it. But it should be interpreted from the left to right. Now, if you want to, okay, can someone tell me how do I convert A into binary?
1010.
Remember, this is a hexadecimal. Okay, someone
65.
1010. Why?
A means
Hexadecimal
A.
10, 8421. 8 and 2 is 10.
Okay, very good. So A, I told you that this A is a hexadecimal character. So A is represented as 10. Now, how do we represent 10 in binary? Is this correct?
Yes, sir.
And now the next one is the 4. So how do we do it?
0100.
Okay. This is the representation for 4A. Now after that, we will go into the 5. So how do we represent 5?
0101.
Is it correct?
Yes, sir.
Okay. Maybe I would need that table for once.
No, these are correct.
No, I just need this table in order to interpret the prefix bytes.
Yes, now this table I am not able to understand.
Okay. Okay, let's try to understand why do we need this table and how it's gonna help us. Okay.
So do we need to remember this table?
No, you don't need to remember this. You could simply use this table for the reference.
No. Suppose in exam, the problem is asked to convert. Then
You
in
should
that
be
case,
given this table in that case. The table should be.
it will be given, na, sir?
Yeah.
Okay.
You are not required to memorize anything.
Okay, sir. Thank you.
Okay. So now let's understand why do we need that table. Now, can someone tell me how many bits are there in total?
5, sir.
Sorry.
28 bits.
Okay.
Total
see,
bits.
we have
It's
8
16
bits.
and
20.
20 bits.
We have 8 bits here. So these are 16. And this will make it 4. That is 20. Now, even if we will ignore this leading 0 here, as you know, that keeping zeros on this side, on the leading side in binary doesn't make sense. If you are making 101 and you are writing as many as zeros, that would also result in the same number, that is 4. So maybe you could write so many zeros here, as many as you want, but you should not remove the zeros after this one, right? If you will remove this 0, that would actually be wrong, right? You couldn't do that. Now, if we will go on to the table, let's go to the table once, right? So here you are saying that if you can represent a character or a Unicode code point in 1 byte, so you should have 7 bits. You cannot encode a character in just 1 byte if you have more than 7 bits. Now, if you could count here, how many bits we have? We just counted it as 20, right? Right? We just counted it as 20.
Yes, 8 plus 8 plus 4.
Yeah, even if you will remove this last 0 from here, let's remove this. Then we will have 3. Then also we will have 8, 8, 16, 19. So we will have 19 bits, right? But will you be able to fit this 19 bits here in this place? No, you won't be, because it can only handle 7 bits. Now let's move to the second row. Here, it can handle 11 free bits. So how many bits do we have? We have 19 bits. We are not even able to fit those 19 bits here. Now we will move to the third row. It can handle 16 free bits. Do we have 16 free bits or more than that?
More than that.
How many do we have?
19.
19 or 20 for now, we can say anything. Now, when we will move to the fourth row, so this is saying it can handle up to 21 free bits. So yeah, we will pick up the first row here and we will try to put the prefix as required. But let us see, it is requiring 21 free bits. But here, even if we will consider this 0, even if we will consider this, we will have just 20. We somehow need to make it 21. Can someone tell me how can I make this whole sequence a 21-bit sequence?
One more 0.
One more 0 on left hand side.
We just discussed that adding one more 0 onto the left doesn't make any difference in the interpretation, right? This would again this would again be interpreted as 4. Even if I will put 10 more zeros here on the left hand side, this would be interpreted as 4 only. Is this correct? Is this okay?
Yes.
Okay, so now we have 21 free bits available. Now, what shall we do with those 21 free bits? We should again refer this image, as this is saying that the first byte of that number of that UTF representation should be calculated as this. How? That means we have to keep the first bits constant. This should be 4 times 1 and 0. So let's try to keep this. Okay. So I'll just make the columns. This is for first byte. Let's say this is for second byte. Please let me know if there is anything that you are not able to understand, right?
No, that particular table itself, I'm not able to understand. Like, what is this 7 free bit is okay, but then how come next row is 11, then next row is 16?
Yeah, this is actually a standard. This is how the UTF-8 characters are represented into the memory. Now, why do we need these many rows? Can someone tell me? Okay, that's a really good question. So can someone tell me, why do we need these much rows? Forget we don't have any table. Forget we don't have anything. What will happen in that case? Let me try to explain that. For example, suppose we have a number represented with these 8 bits. Let's say, let's take the example of capital A itself. Right. Let's say capital A. And as you know, this is represented with 65. And this, how shall we represent it in binary? 1. Yeah, this is how we shall represent A in the binary. Is it okay?
Yes.
Yeah. Okay. So suppose we are representing A with this sequence. Okay. Now suppose I have a sequence, let's say 1, 0, 0, 1, 0, 0, 0, 0, 0, 1. And suppose this belongs to a different Unicode code point. Let's say this is representing 41, U plus 41. And let's say this is representing something else. Let's say 98. I'm just taking a random number. Okay. Now, how will you interpret it? How will you understand that this is a different number? Because the computer will treat this thing. I guess I have made some mistake here. 0, 1. Just a minute. Let me remove this. Yeah, let me just type it one more time. Sorry, just select the pen.
Please use below part. I mean, there's more space there.
Okay, actually, I just wanted to keep this part reserved. All right, okay, I'll just delete it afterwards. So yeah, 1, 0, 1, 0, 0, 0, 0, 0, 1. Now this is a different code point. I don't know what the code point is, but I'm just saying that this is a different one. Okay, this is not the same one as we seen before. This 41 that represents 8. Now here, you know that this is a 9-bit sequence, right? This is a 9-bit sequence, but out of those 9 bits, these 8 bits are representing another character that is A here, right? These 8 bits are corresponding to this A.
Yes.
Now this would become really difficult for the computer to understand that this is exactly this is a unique character. This is not A. Suppose if the computer will interpret it as A, what shall the computer do with this? Now suppose we have some other encoding, some other rules defined. Let's say if we have just one, maybe we would consider it as a space, right? Let's say space A. But is it the answer that we were expecting? No. This Unicode actually refers to a single character. It could either be a space, it could either be a A. Well, that's a different thing. It can neither be of these. I'm just taking a random example. I'm just trying to explain why do we need this table? Why do we need this standard in order to interpret things? The reason is this, that whatever sequence has been decided for a particular character, the same sequence of bits should never be encountered in the interpretation of a different character. That is the idea. Now let's just look at the image again. So you could see here that if a character can be represented with just 1 byte, so what you can make out of it is that the first bit of the first byte will always be 0. If you encountered a byte where the first bit is 0, you could close your eyes and you can say that that's an ASCII character. And suppose you picked up one more byte, you found, okay, that byte is actually this, looks like this, 1110 and some other set of bits. Now here you could close your eyes and
sorry to interrupt. See, 1 byte is 8 bit, correct?
Yeah.
So 8 bits are like 8 different signals.
Yes,
so if the leftmost signal is 0, so and then second, I mean the 7th from the right, I mean, yeah, after 0 also, suppose it is a 0.
Okay.
In that case,
no, we are not worrying about the other things. I'm just worrying about the very first bit of that character, of that byte. Suppose you are going through a random memory dump, right? You don't know which byte belongs to which character. You just picked out a random byte from that memory dump, and you saw that the first bit of that byte is 0. What can you make out of that byte? If the first bit is 0, you could easily say that it's a character. It is representing the whole character, or it's an ASCII character, right? Because you will never find the same sequence as part of another bit. As part of another byte that has 0 as the first bit. Can you see in this table any of the sequence of bits that is using the same sequence? First bit is 0, and let's leave the other characters, the other bits. This is using 110, this is 10, 11, 10, 10, 10, 4 times 0, 10, 10, 10. No other byte can match this sequence, right? This is reserved for ASCII. That means if the first bit is 0, the rest of the 7 bits will represent the ASCII value. Is it making sense?
Sir, you wanted to say that every code should be unique. That is what?
Yes, definitely.
Okay.
Definitely. That's what I'm trying to make you explain here. That a sequence of bits that is representing a particular character, the same sequence of bits should never come in the representation of another character. As I explained you, that suppose this, this is the sequence of bits that we are using for representing A in memory. Now, the same sequence of bits should never encounter while representing any other character. That is the idea. And suppose if this is understood, is this understood to all?
So this makes a sense while decoding, we won't face any problem.
Yes, of course, because computer, how the computer is interpreting, computer don't know anything. Like
yes,
even if you are reading it, you won't be able to find out anything here.
Yes.
So there should be some standard so that computer can understand how to interpret a particular set of bytes or bits.
Yes, sir.
No, suppose first bit is 0.
Yeah.
And then all other, this is for the first byte.
Yeah.
Even in the second byte, the first bit cannot be 0. That is what
you could see. The second byte can never, the first bit of a second byte can never be 0. You could see in this.
Or any other byte.
Sorry?
This, the first bit of any other byte, I mean, third byte also is
cannot be 0. Cannot be 0. Yes. This you can even say while closing your eyes. Yes.
Suppose hypothetically, first bit of the first byte is 0.
Yeah.
And first bit of the third byte is 0. What does that mean? I mean, any kind of overlapping or what?
Yes, definitely. This would confuse the computer. How should we interpret that? Because what we are saying is we are just freezing the first bit. We are not freezing the rest of the 7 bits, right? Now, suppose you are saying that I am keeping the first bit same. I am also keeping the second bit same. The first bit of the second byte same. Now, we are not concerned about the rest of the 7 bits. It is quite possible that the set of 7 bits that you are using here, you can also use those. Yeah, there also.
Okay, so it's kind of double A, not a different character.
It will be ambiguity. Yeah, it would call ambiguity in the computer. right? So if the first bit of a byte is 0, you could easily say that it is an ASCII character. Now, if you will move ahead, let's move to the second byte. Okay, we'll come to it later. Suppose if you are going through a sequence of bits and you saw that one of the byte has the first two bits as 1 0. Can anyone tell me what can you interpret out of it? If the first two bits are 1 0. Anyone would like to say?
It's UCS2.
No.
It means it has more than eight bits.
Okay, very good. Yeah, you could say that it's not a character that can be represented with a single byte. It
Single
requires
byte.
more than that. Very good. Yeah, so that is the observation that you could find out from here, that if you encountered a bit having 1 0 as the first two bits of that byte, you could easily say that I am not going through the first byte of a character. Because you could see that if we are saying first byte, the first two bits of the first byte are never 1 0. It is 1 1 0, it is 1 1 0, it is 4 times 1 0. It can never be 1 0. So if you are going through a sequence of bits that has the first two bits as 1 0, that means it's not the first byte. You could not say that it's a second byte, it's a third, or it's a fourth. You could only make an assumption that it's not the first byte. This is the only thing that you could do. And what the computer will do, computer will say, okay, this is not the second byte, so I should look here and there. I should look onto the left, I will find the first byte. Or if moving on to the left, again the computer see that the first two bits are again 1 0. That means again, that is not the first byte. Again move to the left and see if the first two bits are 0. Again, if it is, then move again.
So if first two bits are 1 and 0, then it has to keep looking towards its left for another set of 8 byte bits until unless it finds a sequence of 1 1.
Yeah. Yes.
And it cannot be again, I mean, the leftmost will definitely be 1 1 sequence. It cannot be 0.
Yeah, definitely, it will find some after repeating the same process for 2 or 3 times. This would definitely find at least one of these, right? 1 1 0, 1 1 0, or something like that, right? Yeah. Is it okay?
Yeah, is it by convention or it's designed like that?
Sorry?
Is it a convention or is it, by design it happens?
See, it's a standard. This is how the computer is programmed in order to read these bytes. So you could say it's a standard. Is it clear?
Yes, very clear.
Okay, now anybody has doubts that why do we need this table? What will happen if we won't have this table?
I think I'll have to give more time to this. Let us come back to the question.
Okay. Yeah, maybe you could try solving these things first, and maybe we can discuss it again. Okay, so what I'm saying, sorry, this is a eraser. Yeah. Okay, so what I have written here is I have written the first byte, second byte, third byte, fourth byte. So let's get back to the image again. So as we already have discussed, why are we using fourth row here? Because we need 21 free bits. The third row is only capable of handling 16 free bits, but we have more than that. That's why we have to take the fourth row into the consideration. Now, according to the fourth row, the first 5 bits of the first byte should be the same, or should be 4 times 1 0. So let's just put it. Okay, the first 5 bits 1 1 1 0 0. The rest of the 3 bits we will fill here 1 2 3. We will fill here. Okay. Now, what can we do for the rest of the bytes? The second byte will have the first 2 bits for sure 1 0. Same with third, same with
The first byte has 4 ones and 0.
yeah, 4 ones and 1 0. Yeah, 5 bits are reserved. That's what I have done here. Okay, sorry. Yeah, thanks for pointing it out. Okay. So 4 times 1, 1 0. And here for second, third, and fourth bit, we have just first 2 bits standardized. That is 1 0. The rest of the 6 bits we will take from OR sequence, OR dump. Here also 1 0, 3, 4, 5, 6. And here also 1 0, 1, 2, 3, 4, 5, 6. Okay. Now let's try to fill out whatever we have. Okay. So here, let me just try to put it in a clear way. So it is 0, 0, 1, 0, 1, 0, 1, 0, 0. I'm just copying it from here. Okay. 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 0, 1. Okay, let me just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I guess we have more than 21 bits here. 1 0 0 1, 0 0 1 1, then 1 0 1 0, then 0
It's
0.
21 only.
It's 21. Okay, all right, fine. Yeah, so now we will try to pick the first 3 bits from the sequence and we will put it in place of first byte. So we will pick this 0 0 1 and we'll put it here 0 0 1. So the first bit is done. Now we will put the rest of the bits in the second byte. How many bits do we require to put it here? 6 bits. So we will just take the next 6 bits. 1, 2, 3, 4, 5, 6. So it is 0 1 0 1 0 0. 0 1 0 1 0 0. Now we will take the next 6 bits again. That is 0 1 0 0 0 1.
No, 1 0. It will start with 1 0.
Okay, sorry. So 1 0 1 0 0 0. Okay, sorry. Yeah. So it would be 1 0 1 0 and then 0 0. Is it correct?
Yes.
No,
1 0 1 0 0 0. Yeah, I guess it is correct.
Yes, it is correct.
Okay, the fourth byte is will start from the
1 1 1 0 0 1.
so 3 times 1 and then sorry. One, 1, 1, 0, 0, 1. Now this is the final UTF sequence, I would say, the set of 4 bits that we have come across. Now what we need to do is we just need to convert this binary sequence back into the hexadecimal. So the way we started this question, we converted the hexadecimal into binary. We will convert this binary into decimal. So we'll just pick 4 bits at a time. What will it make? 1001. This will make 9, right?
Yes.
What will it make? 1011.
B.
Okay, this will make B. Okay, if you will consider these four bits, then
8.
okay, it will consider 8. This one,
A.
sorry. Is this 81010? Okay, 8.
Yeah.
And then this will 0100.
4.
This will become 4. 1001.
9.
9. 0001.
1.
1. And this 111.
Yeah.
Is this the sequence? Oh, sorry. Is this the answer?
Yeah, but why are we taking in the blocks of 4?
Because it is we need to get the answer in the hexadecimal. Hexadecimal character is represented using 4 bits.
Okay.
F1. Can someone please confirm this answer once if this is correct? I guess it should be.
Sir, are there any coding standard which are more than 21 bits now?
Sorry.
As we are having maximum 21 bits here with these coding standards, is there any other coding standard where the size is more than?
You will never find any code point that would actually require more than 21 free bits.
Yes, sir.
I guess there's some problem in the answer.
Yes, answer is not matching, right?
Okay, answer is not matching. Okay, let us just try to go through again. 9 means 1001. 3 means this, correct? A means 10.
Sir, in question it is 543A9.
Okay, 543. Okay, so we just reverse some things. So according to this code point, the answer will be this.
Yes, sir.
Yeah, no issue. That we can figure out.
I guess you at least got to know what's the method or what's the procedure in order to compute the answer.
Yes.
Okay, I missed that thing, I guess. Someone wrote it in the chat also. So anybody has any doubt? How do we solve this? How do we calculate the computation?
Few more working exercise problems might be required.
Sorry?
For brushing up, few more questions might be required.
Okay. Okay. Is it clear?
I mean, for self-practice. Yes, this is clear now.
So this fourth row is called UCS4 or UTF-32?
Sorry?
The fourth row.
Yeah, this one?
Yeah, that is called UCS4 or UTF-32.
No. Please don't confuse between UTF-8, UCS4. Right? This is a UTF-8 representation. UTF-8 is a variable length encoding. That means UTF-8 can also represent a character in 1 byte, in 2 bytes, in 3 bytes, or in 4 bytes, a maximum of 4 bytes. So it cannot go beyond that. Okay. That's why we are using UTF-8 as a standard one. Why? Because it is capable of using only 8 bits. That means 1 byte for the most common characters or the ASCII ones. For some other languages that would require some more bits to store, that would use 2 bytes. For some other languages, more complex languages, it will use 3 bytes. And for some other ones, it will use 4 bytes. So depending on the content, what language type you are using, or what type of characters, or whatever language you are using in your web documents, the UTF-8 will accordingly compute the size. And that's why it is the most efficient one. Why? Because if we will try to compare it with some other ones, let's say UTF-16. UTF-16 is also a variable length encoding technique, but that will use either 16 bits or 32 bits. That means either 2 bytes or 4 bytes in order to represent a single character. Now, let's take an example of a case where a web document uses only the characters that can easily be represented using the ASCII. But still, if we are using UTF-8 as the encoding technique, it would require 16 bits in order to encode a single character. At the same time, UTF-8 will just use 8. Right? So at the end, you could compute the memory difference, the storage requirement, right? It would be much less as compared to other encoding techniques.
Suppose if we wanted to encode from Unicode 8, the same example, to UTF-16, then what would be the steps?
Yeah, there are some other
we would require different table then?
Yeah, definitely. There are some other standards to do that. When you will go into, with respect to this course, we don't want to go into those much details, how this is required, how this will be computed. Why do we need this? Why do we need to understand this thing is, as a web developer, suppose you are creating a web app, and at a point, after reaching a certain point, you want to internationalize your app. For example, suppose your website is just supporting English characters or maybe some of the other Indian languages, right? Now, later on, you want to internationalize it. You want to use some other foreign languages. So, of course, you will need to, see that what other encodings that I can use and why do I need them? We don't need to go that much into the conversion. This is just a standard for UTF-8 we have just shown you here. But as a web developer, you might not be too much concerned about it.
So why is the maximum expressible Unicode value 1 less than 2 to the power of 3 bits?
1 less than 2 to the power of?
2 to the power of the number of free bits.
Okay, yeah, this number, you're talking about this number?
Yes, yes.
Okay, so this is actually, actually
What
UPS
happens to that extra bit?
Which extra bit?
Not extra bit, that additional expressible value, because 2 to the power of 7 is 128. What happened to that 128?
It is just showing that what is this mean. What does this mean? 007F means 127.
Yeah, that is maximum expressible Unicode value. So I can express 127 values like that.
Yeah, a maximum of 127 can be represented using 8 bits or using just 1 byte. If you need to represent more than that, you will have to go and use 2 bits, or sorry, 2 bytes. Right? So 128 to 2047 will require 2 bits. 2048 to 65,535 will require 3 bits. Sorry, 3 bytes. And then after that, it would require 4 bytes. This is how it works.
Okay. Thanks.
Yeah. So is there any other confusion regarding this? Yes, anyone?
Yes, no.
Okay, I hope at least the procedure is clear, how to convert it. Please let me know if you have any doubts at any stage.
Yes, so if it is like the only thing is that if the number of bits are say 17 or 18, I have to make it either 21 by adding number of zeros.
Yeah, definitely. So of course, you will have to look out for. See, if suppose you have a number, let's say you don't have 5 here, right? You just have 4A39. If I talk about 4A39, so it is okay. These 16 bits are okay, right? You don't require any other thing. You can easily put 000 there, right? If there is a code point that is 4A39, you computed that it can be represented in 16 bits. So you don't need to go to the 4th row. You can easily compute the answer using this, a 3rd row. You will only require 3 bytes in that case. You don't need to go for the 4 bytes. So the conversion will become a bit more easier, as you don't need to convert one of the byte into the hexadecimal at last. Am I making sense, or shall I show you with the help of an example?
No, yes, because see, writing the first, I mean, all these 3 blank spaces and then filling up those blank spaces from left to right.
Yeah, definitely. Okay. So see, if 4A39 is the only sequence, we will remove this 5. So we don't require this extra bits, right? This will be discarded then. We can only work with them. And these are 8 plus 8, 16 bits. This could easily be represented using the 3rd row. That means 16 free bits. So whatever the sequence there will be, let's say 1, 1, 1, 0, 1, 0, 1, 0. And here the rest of the bits we will fit in from here, right? At last, we will just compute the hexadecimal answer.
Yes, thank you. And one more thing, see, many of the questions are like someone who has already done HTML or CSS can easily figure out. But I find that many times I need to search for the answers.
Okay. In that case, I would strongly recommend you to please, join the Solve with Instructor sessions and please ask whatever you want. We'll try to keep that session.
No. Like suppose a particular question is like, say, regarding the syntax, which syntax is correct or what is, what should come. So many of the things, I mean, someone who is doing this for the first time in life.
You went on mute. I can't hear you.
Oh, I'm sorry. I'm saying that someone who is doing this for the first time and question is about syntax and all, which suppose is not covered in the lecture, then one will have to look for a search for the answers elsewhere, correct?
Okay, yeah.
So is that
a little bit of research is definitely required from your end also, some efforts.
Yeah, that I understand, but only if if one comes across the question, then only one will look for the answers somewhere else.
Okay.
So suddenly, if one say suppose 100 such questions one goes through, and suddenly some different kind of question is asked in the quiz, and which one has not gone through earlier.
Okay, there is one more thing I would like to make clear here. That there won't be synthetical questions in the quizzes. The questions will be self-contained. You don't need to memorize any of the thing while attempting those questions. That is for sure.
Yeah, so what I gather is that all these activity questions and practice questions are pointing to one, I mean, helping one to learn as many syntax and as many practice one can do through these questions.
Definitely.
Okay.
Someone was trying to say something.
No, I am saying that like in Python, in our foundation course, there
are
practical questions. So you need to know the logic and they are giving them. Because in HTML, too many tags are there. Nobody can remember. Even like us who are developing, we cannot remember.
Yeah, definitely. I completely agree with you that it's not possible to remember each of the HTML tag or even the CSS properties. Of course, it's not possible to memorize all of the things.
Like when you ask about the block, okay, in our format, what we are doing, we have templates like these are panel body, these are panel inline. Okay, inside that we return the CSS. So we are just putting the width and it is automatically taking the inside that inline block. Okay, so that's why you told width. Internally it is what you told, that's correct. Inline, it's taking the inline blocks. So it's difficult to remember all the things.
Yeah, sure. I completely agree with you. Completely agree.
So even these CSS shortcut codes like border is equal to 1px solid white. So the order in which it is asked, these kind of questions will be asked for the quiz?
No. I mentioned that whatever questions that are more specific to the syntax, these questions will be avoided during quizzes. That would actually involve the logical component more.
Okay.
The memorization, we don't want you to memorize, very or maybe many things. Yeah, of course, maybe a little bit of knowledge would definitely be required, but I am saying that synthetical questions will rarely be asked in the quizzes.
Okay, thank you.
Most of them will be the logical problems.
Sir, I have a question regarding lab assignment.
Yeah.
So in the second part of lab assignment, the CSS part, there are some instructions how to do that, and we have to use external CSS files. But in the tags, that how many tags we can use, and there is no mention of link tags. So we can use and we cannot link external CSS files without using link tag. And but there is no mention of using link tag in the mentioned tags that we can use in that particular lab.
So whoever is asking the question, I just wanted to clear one thing, that whatever tags that have been specified with the frequencies, it's been mentioned that those are the tags that should be used inside the body. So outside the body, you are free to use tags.
Okay, sir, got it.
So head tags, meta tags, yes, definitely you are okay, you are fine. The restrictions are there inside the body.
Yes.
Well, I saw one query in the discussion forum also. I guess there was some confusion with the nth child. As far as I remember, someone raised that thread. So maybe I would like to take.
I had raised that odd even thread, and you have posted also.
Okay. Did you get the solution or still you are facing any confusion there?
No, confusion is not there. Only thing is that the what is mentioned that TR is a child of T head. That is why it is behaving like that. But my question is, if that is the case, then the header is overriding to yellow, and the just next TR, I mean, just first row also is going to yellow. So header and the first row of the content of the table, both are becoming yellow. Why so? If odd, odd will mean the one will be taken by the header and then third will be taken by the third row. I mean, starting from the header.
Okay, let me try to come on that question. Let me see if I have that HTML file. I guess this is the one. Is this the same file?
Yes.
Okay, this is the same file. Okay, so now let me try to clear your query. What you have done is you are trying to put a property background color, whatever the color is, on the TR, right? On the odd children's, on the odd occurrences of TR, right?
Yes, I mean within the style head, in the head, style is there. Yes.
Okay. So see,
what
what is happening there is you will have to look out for the parent. Who is the parent of this TR? The parent is T head, right?
T head. Yes.
Now, inside this T head, it will count the occurrences. So this is the first TR. That means this is the odd occurrence, right?
Yes.
Do we have any other occurrence of TR inside this T head?
No.
No. So this will be ended. Now, if you will talk about this TR, so this has a different parent. This has a T body as the parent, right?
Okay. Yes.
So this TR will be considered the odd one, the first TR element for this keyboard. That's why both of these TR are coming in the same tag.
There are two odd TRs here then.
Yeah. So both of them are treated as odd. The reason is because both of them have different parent. It has T head as the parent. It has T body as the parent.
So suppose hypothetically there is another T body between T head and T body. Then there will be 3 TRs which will be treated as odd.
No, why? If you have one more T body here, where will you end that T body?
No. Suppose I will just giving hypothetically, instead of T body, some other tag element is there between T head and T body, which is having a child as TR.
Okay, yeah. So that would be considered as a separate hierarchy. And whatever the first element is, that will be treated as odd. And when it will come to T body, this T body, it will again be considered as the first, the odd one.
Okay, got it. Thank you.
So yeah, I guess I tried to give you the solutions as well. Maybe you could try to style the TH tags, or you could simply assign this TR as maybe an ID. You could do that.
So there is no way of putting this nth child inline style?
Is your voice breaking, or there's some problem at my end?
No. Someone else, Cherry and George asked another question.
Is there no way of putting the nth child as a inline style?
Can you please repeat?
Is there no way of putting this nth child property as inline style?
Cherry's voice is coming clear to me.
Because there's some problem at my end. Hello, now am I audible? Sorry, I guess
Yes.
there's some network interruptions at my end. Is there no way in which the nth child property can be specified inline? So see, this nth child is basically a pseudo property, right? And what do you mean by inline? Inline will only be applicable to just single element. So of course, that won't be encouraged and that can't be even done. Because see, if you are talking about inline will only consider a tag at a time. What do you mean by nth there? There is nothing related to n, right?
No, suppose there are so many entries, and if I go to particular entry and hard code the style of TR over there, and I also have this style block in which I have this nth child as odd or even mentioned. So will that hard code override this style?
Hello, am I audible?
Yes, yes.
Okay, so you're asking that hard code to be done within the tag, right? Inline.
No, I mean, in the table, suppose there are 100 plus entries, and we are doing it through the style, doing the TR and its child, odd or even.
Okay.
And one of the entries I have also hard coded the TR tag over there. So will that override the style which is already given in the style tag, or the style tag will override this?
Okay, so both of it you are hard coding in the internal CSS.
Yes, internal CSS.
Okay, so in that case, the sequence, like if your code says the end child thing first, and then the hard coding of that particular element, then the element will be overwritten, will overwrite the previous one, right? And the other way. So you're getting, so the sequence depends here. The latest one will be overwriting the previous one. Hello.
Hello. So suppose there are 100 entries, and for all the, if I'm not hard coding anywhere inside the T body, and it's just under the style tag, then it will be working as an alternative sequence, correct? And suppose in addition to that, for the 51st entry, I'm hard coding to some other say, suppose some other color than the style tag. So just for this alteration, whether the 51st tag will be taking the new hard coded one and all other odd ones will be as per the style tag?
See, the condition which you are saying will happen if the 51st, the styling of the 51st is provided after the styling of other tags. So what I'm trying to say here, the sequence matters. What will overwrite what will depend on the sequence. Let's say you
yes, so style is under the head tag, correct? Yes. And all the entries are under the body tag. So definitely style is coming before I'm hard coding one of the entries. So one of the 51st entry which I am again hard coding over there.
So the 51st entry, that's what I'm asking, sir. If the 51st entry which you are hard coding, what is the way in which you are adding style to that? Is it inline or internal?
I mean inline. I mean I'll open the TR tag and then I will hard code over there.
So if it is inline, then that particular tag will be overwriting everything.
Yes. So first to 49 and then 53rd to balance will be as per the style code, and the 51st entry will be as per the inline hard coded, correct?
Only the inline, only the 53rd, because inline coding can be provided to that particular element only. So if you're talking about 53rd TR and you provided inline styling to that 51st TR or 53rd TR, that particular styling will be provided to that 53rd TR only. After that, 54 onwards, It will be following the previous style.
Okay, so 1 to 49 will be as per style tag, and everything after 51st will be as per the 51st hard coded.
No, 1 to 49 will be with the style tag. 51st will be with the hard coding of inline CSS, and 52nd onwards it will be again with the style.
Yeah, that is what I also want.
Yeah. So you can style at a time only one element with the help of inline CSS.
Yeah, definitely. I'll also check it by coding.
Okay. Yeah.
Yeah, if I have understood it correct, are you trying to say something like, for example, you have applied styling to some odd elements of a table, let's say TR, and suppose you picked any random odd element, odd row of that table, and you try to style it in an inline manner, let's say a different kind of style.
Yes.
So will it inherit that whatever you have applied using n style? This is what you are asking?
Yes.
Yeah, definitely. So whatever you will apply at inline level, the tag level, yeah, I should say inline level, that would override all of the things.
Yeah, for that particular entry only.
Yeah, maybe I could try showing you an example. Are you able to see my screen?
Yes, it's visible.
So for example, this T body is here, and what style I'm applying? I am applying for odd children. Okay. So this is the T body. This is the first one, second one, third one. Okay, let's try to put some style here. Okay. This is the odd one. I'm trying to put a inline style here. Background color. Let's say pick a color. Let's say green. Now, what do you think? What should be the output in your view?
The third entry should be green in color.
Yeah, third should be green in color, and the rest will go as it is. That means the first one will be yellow, the third one will be green, and fifth, seventh, they will again be in yellow. Only
Yes.
third will.
Okay.
Am I opening the correct file? Looks like. So yeah, you could see the first one in yellow, third one has changed, and the yellow continues.
Yes. Now it is clear. Thank you.
Okay. Yeah, so I just wanted to ask one more time. How many people do we have? Okay, 9 people. I guess this UTF conversion is clear. This UTF standard, why do we need this standard? I guess this is also clear. Okay, so do any one of you has any other doubt regarding activity or practice questions? Yes, anyone? Uh, so if no one has any other doubt, shall we close this session?
Thank you for the session. Good night.
Okay, so all right, in that case, we'll want to close this session. So thanks all of you for joining in this session. I hope you find this session insightful for you. We'll meet day after tomorrow for the Solve with Instructor session, and there we will learn about HTML and CSS from the scratch. We'll try out some fancy things also. Hope to see you there also. All right, yeah, bye bye everyone. Take care, have a good night.
Good night, sir. Thank you.
Adarsh, would you like to add?
Yeah. So yeah, it was a good session. Good responses from you all, and hope your doubts are cleared. And we'll see you on Thursday. Sorry, Friday. Thanks. Yeah, I think we can wind up.
Okay. All right, Adarsh. Yeah.